So now that we've done a good deal of studying limits, computing limits when if we try to plug it in, we get 0 over 0, computing limits where we can just plug in the number, let's look at another situation that can happen. Let's look at something like the limit, the limit as x goes to 0 of 1 over x squared. We'll take something straightforward here to start with. So if we try to plug in 0 here, we get 1 over 0. Now, if it were 0 over 0, we could try and do some of our factoring tricks or conjugation or something like that. But here, we're kind of stuck with 1 over x squared. Right? Or sorry, with 1 over 0. So there's nothing we can really do there. But let's look at the graph of this function and see if we can figure out what's going on. Right? So the graph of this function, 1 over x squared, looks something like this. Right? We have something like this going on. So what do you think that means that the limit as we approach 0 is going to be? What could we say about this function? What does it look like the values of this function are doing? Well, if we look at a table of values of this, so here we're going to do x, this is going to be 1 over x squared. If we plug in plus or minus 1, it doesn't matter because this is an even power, so the negatives just go away. This will be 1, right? If we do plus or minus, let's do 0.5. Right? If we do this, we're going to get 4. Let's do, I don't know, plus or minus 0.1 maybe. This is going to be 100. Plus or minus 0.01. This is actually going to be 10,000. Right? Because you got to remember, these numbers are getting smaller and smaller, but they're in the denominator. And if you have a fraction where the numerator stays the same and the denominator keeps getting smaller, the fraction overall gets bigger. Right? There's two ways for a fraction to get bigger. You make the numerator bigger or the denominator smaller. And what's happening here is the denominator keeps getting smaller and smaller and smaller. Right? So let's just do one more here. If we plug in 0.001 or negative 0.001, we get 1 million. That's 1 million. So does your intuition seem right on what this function might be doing as we get closer to the origin? Or as our limit goes to 0? Hopefully it seems to you like it would be reasonable to write this statement. This limit's going to infinity. So, what does this mean? Well, technically, since infinity's not a number, technically this limit doesn't exist. But, even though it doesn't exist, there's still information here. Right? We know both ends of this function are going toward infinity, so we're going to keep that information that we have that we can pull out of this and say that this limit is infinity. Right? So this is kind of the idea behind what it means for the limit of a function to be infinity. Just as we approach that value, the values of the function are getting larger and larger. Right? And I wrote it here for, the two-sided limit. This also completely applies to one-sided limits as well. So like limits from the left. If the values from the left keep getting larger and larger, or the values from the right keep getting larger and larger, then those would also be infinity. A slight difference, let me do another example here. Let's look at the function f of x equals 1 over x. Right? Hopefully you remember the graph of this guy. This one looks something like this. Okay. So this is the graph of 1 over x. Right? Let's look at this one. Right? What can we say about... Let's look at all three of the types we have. The limit from the left, the limit from the right, and the two-sided limit. What does it look like happening here? Oh, sorry. I put the 1 over x. What does it look like happening in each of these cases? I encourage you to plug in some values to the function and see what's really going on. But if you trace out the values of these, you'll see from the left side, right, you're going to keep falling down here, and this is going to go down toward negative infinity. So this is what we would say. Here's a function that has a limit which is negative infinity. If you follow the values from the right side, you're going to see, oh, well, these are just going off to infinity again. And now we think back, to answer this last question of what is the two-sided limit as we approach 0, just think back to when we did two-sided limits before. What had to be true about limits from the left and on the right? Well, they have to be equal. These two aren't equal, so we would still say that this one does not exist. Right here, there's actually no information we can get. Right? But this is the idea behind a limit going to infinity. So let me just finish this off with saying sort of a consequence of having a limit going to infinity. What does this tell us about a function? Well, it tells us that it has a vertical asymptote. Whenever one of these kind of limits are infinity or negative infinity, that means that at this value here, there's a vertical asymptote, right? Remember, a vertical asymptote is a vertical line that the function can't cross. Right? Here's another one right here. Right? Typically what's going on here is a function will start getting closer and closer and closer to that, but it'll never actually reach it. Right? So we'll talk some more about that, get some more details about that in the next couple videos. But hopefully that makes sense and gets you started.